everyone, Athena here from the Astro Athens channel, and today's subject I want to talk about is something known as non-associative quantum mechanics. So I've done a few videos about quantum mechanics generally, so talking about Schrodinger's equation, wave functions, and just generally quantum physics and what it really means to have a superposition of particles or wave-particle duality. So since I've already talked about that, I recommend you guys watching that video first before watching this one so you can understand a little bit about the basics of quantum mechanics and quantum systems. Even though it's not really, there's nothing basic about quantum mechanics, but I also talked about two-string theory and what was the other one? The no boundary proposal. So go watch those videos first before watching this one. Okay. So this is a study that was done a few years ago, but it's been revisited recently and I really want to chat about it. So what a non-associative quantum system is quantum particles behaving in a way that doesn't obey the rules of associative mathematics. So pretty much it doesn't obey the rules of a wave function. So, and it also doesn't really follow standard laws of quantum physics. So, and a perfect example of that is a monopole. And a monopole is like a magnet that doesn't have both a north and a south. It has only a north or south pole. So what ends up happening is through certain mathematics, so non-associative algebra, which is an actual thing, I'll get into that in a second, quantum physicists have been able to find that mathematically non-associative quantum mechanics would show that the particle would start spinning in a loop continuously and it wouldn't stop. And this has to do with this monopole, with there being a singular direction of magnetic energy. Because again, like I said, if you think about a magnet, right, very, very basic, a magnet has, I need to get a magnet. A magnet has two sides, it has a north and a south pole. The north and the south pole are going to be attracted, and if you have a north pole and a north pole, they repel. A south pole and a south pole, they repel. But if it's one magnet, has two different sides, it has a full electromagnetic field around it. But what's happening is if you have a magnet with only one pole, a monopole, so just a north or a south, a negative or a positive, it's only transmitting an electromagnetic field from one end. So it causes any type of nearby particles to just spin in a direction around that. So this is really fascinating to think about because this might be a whole new understanding of quantum physics and how quantum mechanics works. Now, let me tie in really quickly with you guys about why this is so important. So phones, right? So my phone right here. This has something known as a quantum chip inside. So we actually use quantum physics and quantum mechanics in our everyday technology. We use it all over the world, and we're going to be able to use it in future technology and future, I can't even imagine what type of systems we'll be able to eventually incorporate this with. Actually, another example is we can use quantum physics for something known as quantum entanglement, which I've talked about quite a lot, but for those of you guys that are maybe new to my channel and don't know much about it, quantum entanglement is when you can entangle two quantum particles with each other, right? They have similar properties. And when they entangle, it's kind of like imagining an imaginary bridge between the two of them. And what you can do is you can actually swap their positions in turn, kind of creating a quantum teleportation. So China actually achieved this. They had one particle up at the space station and one down here on Earth, and they entangled them with each other, and they were able to achieve quantum entanglement, which ended up resulting in like quantum teleportation because they swapped those two. So another thing would be too is that you actually would break down the properties of one of them and reassemble the properties somewhere else, and that would be an example of quantum teleportation, but I don't need to get into that. Now, the reason you don't have this circular motion when it comes to standard quantum mechanics is because you have, first of all, the magnetic field, but then you also have the linear force that's acting on it, which actually cancels out that circular motion. But when it comes to non-associative quantum mechanics with monopoles, there's an additional force which cancels that linear force, and it allows for the circular motion to actually continue. Now, this is very theoretical, but the way that researchers are actually working on it is they're creating condensed matter consisting of quasi-particles in a lab. They said that it might take a few years to really thoroughly complete this project, but it is something that they're actually working on right now. And it would be so fascinating to find out if they can actually make this in a lab, because if they can, then it means that it's actually happening in our universe, and it's actually happening in quantum systems, but we've just never observed it before until now. So it's really fascinating, and it's just so interesting to me, the fact that, like, you know, I remember learning about magnets when I was a little kid in school, and we had just like a standard magnet. But to think about having a monopole where there's just a north or a south pole, and having that linear force of the magnet acting on the electromagnetic field, like canceling out, you know, the circular motion. But when you have, you know, just a one-sided magnet, then you have that additional force, which is that opposite end, by the way, if I didn't make that clear before, that additional force that's canceling out the linear force is that extra end of the monopole that doesn't have the south or the north pole. So it only has a one side. The other side is that extra force. So it now allows for the circular motion to actually occur. And I mean, I just think about it in a sense where, like, well, if I have a circular motion, that's a loop, it's a quantum loop. And so we might be able to use that, I mean, in future technology. I mean, first of all, the fact that we use quantum mechanics in phones and in technology today, imagine using something that actually can consistently loop. You could probably use it for so many different things. I mean, what would you guys think? What do you think we would be able to use like a loop for that's on a quantum scale? Something that just constantly keeps looping in a magnetic force. We can probably use that to just be like a power source, to just over and over again be generating something automatically. So it's just fascinating. I think it's really cool. I hope that these researchers can really work out something with this condensed matter using quasi-particles, which would just be like fascinating. So I just wanted to share that with you guys. I think that this stuff is very fascinating, and I also hope I didn't talk too fast in this video, but hopefully you guys like that. And my little Schrodinger cat is sitting down there right now. He is not in a box, so he is very, very, very well alive. Anyway, thank you so much for watching this video, and let me know if you guys want any other videos like this. Leave a comment below, and stay tuned. Every single Thursday I'm going to be posting a new episode from my new series called Cafe Astro Athens, where I cover a new topic in astrophysics over a cup of coffee. And it really varies on the cup of coffee. Like last week I spoke about gamma ray bursts, because they're very brief but very powerful electromagnetic events that happen in our universe. And a cup of espresso is very brief but leaves you a lot of caffeine and energy right after you finish it. So I'm going to be doing more stuff like that. And if you guys like this video, please be sure to subscribe. And if you guys want to help contribute to the show, I'm going to be traveling to a whole bunch of new locations, maybe doing rocket launch chases. Head to my Patreon channel. So it's patreon.com/astroathens. All right, thanks guys. Bye.